Hey, good evening, everybody. Let me find, let's see, today is, January 27th. We are at session 7, already into the course. And lots of good stuff happening. If you're feeling that things are starting to heat up a little bit, there's more stuff going on, you're absolutely right. We're starting now getting into the part of the course where the projects kind of come fast and furious. There's one assigned every week. There's one due every week. And in between then, we'll be learning more techniques for writing code, for dealing with real world projects. And so tonight we're going to be talking about continuous integration and what that can do for you. And then we'll move on to things like refactoring next week, of course, with pairing and mobbing interspersed. So lots of good stuff. Before we get to that, I wanted to open up for Prime Minister's questions. Got some questions about Project One and how people are doing with it and everything. And I want to spend some time now just answering any questions that you do have. I hope everybody's well into their Project Ones. Have started writing unit tests for it. Have started writing integration tests for it. There's some good discussion on Slack about integration tests and some of the challenges that people are finding. But what can I tell you? What would you like to know about Project One? Yeah.
So, I've got a couple of questions. The first one would be, how do you put them together, the instruction commands?
README, yeah. Uh-huh.
So, for the read command, that's just posting that file out, or is it put into like usage?
Oh, good point. Yeah, the README should be more than just command line usage. If you want to have usage there, fine. What's really most important is that, and actually this is all, as you probably recall, this is all explained in the how to document your projects handout. This explains what the README is all about. And the README is not out of the java.comments. The java.comments are the java.comments. Nope, this is a separate piece of functionality. This is something that your program should do. Your program should print out the README when the -README option is provided. And as I mentioned here, there's this Project One test, unit test, that explains how to load the README as a resource. And we've talked about this a couple of times, but I want to reinforce it. So if we look at Project One test, that's over here on the left. So actually, I want to move over to the right. Excuse me, move to opposite group. Okay, I'll get rid of this so I can see it, and I'll make me small, no one can see me. As I think I mentioned last time, Java has this notion called resources, which are files that are bundled with the application. And I just want to make sure, okay, awesome. Yeah, Greg, I'll get to that question here shortly. Java has the notion of resources, which are files that are bundled with the application, put into the jar file. I think I showed you the contents of the jar file last time. Now it has the README and things like that. And the way your program accesses those those resource files is by using the get resources stream method from some instance of a Java line class. And what this does, it'll look in the same package, if you will, for that resource file. So then readme.txt, sorry, let me sort of collapse everything. If you look here in the source main resources directory, there is a directory hierarchy that corresponds to the package name, edupdxt Joey Whitlock, and it contains this file, this readme file. So this is a text file. And what we have over here is some code that you can go off and look at the Java I/O lecture to understand what all these things are, like a buffered reader and an input stream and things like that. But here's how you go about reading the contents of the of this resource file one line at a time. And so this example code here is to give you some ideas of what you could do in your main class to read the README file. It's pretty much all the same, except that instead of insert, you just print out standard output. So this is the mechanism by which you can have your README in a file, so it's easier to edit than say just a big old static string that's there in your source code. You can do that too, perfectly fine. And hey, if you spend 20 minutes, pulling your hair out because the resources aren't working for you. Yeah, just like hard coding a bunch of text, and things might make more sense after you've watched the Java I/O lecture. But that's the intent here, is that I'm giving you an example of how to use a resource file to contain your README, and then your program just reads it and prints it out. Yep, so that was the README. Was there another question that you had? Forgot it. Yeah.
How would you, what's a good way to test, for example, if I want to write test for,
Yep. Oh, yeah, okay. Yeah, how to write, okay, yeah. So integration tests and testing the command line is, an important concept to understand because you're going to be doing it for like the next 4 projects. So let's take a look, and actually, let's go back to the view here so you can sort of understand where all these files are. So at like the very top level of the airline, there's the source, and there's a number of different kinds of source, including tests and main. There's also IT for integration test. And so then this has a project 1 IT, which uses this invoke main test case. Oops. And I guess, yeah, I did a bunch of work on the integration test for the student class, and that's in that part 3 of the of only last Wednesday, 2 Wednesdays ago class. That bonus screencast was all about integration testing and main methods. So that will give you some more details, but yeah, let's go through, and I will just write a happy path test case for the airline program. So let's see here. Here is the assignment. I just want to make sure I get everything right here. So I'm going to look at the command line. All right, there's the arguments and the options. Okay, so let's write this together here. So we're going to say this test is going to be print option prints valid flight to string to standard output. Okay, so there is this invoke main method that takes a bunch of, a variable length array of arguments, and you use it thusly. You're going to say invoke main, and then you're going to give it the arguments. So let's see here. The first argument is, and this is simulating the command line, essentially, the name of the airline. So, airline name. And then the flight number, it's got to be a string, 1, 2, 3. And then the source, we'll say it's going to PDX. And then the depart time, so we'll say, what is this? It's 127, 2025, oops, at, let's say 6, so we'll say 1800, it's 24-hour time. And then, and so like note here that the dates and time are separate command line arguments. And the destination and the arrival time. So let's say that we're going to Las Vegas at, we'll arrive tonight, 27/2025, at, let's say it takes 2 hours. I don't remember how long it takes to get there. Oh yeah, and this is going to be, we need to have a dash print in here. So this is the command line. So those are all of the arguments. And then we're going to want to take the result of this and assign it to one of these main method result objects, or a variable type main method result. And then result gives you all sorts of things you can do with it, like you can get the text written to standard output, to standard error. We're not going to use toString there. So what we want is we'll want to assert that what was written to standard output, and we'll say contains string, and then whatever the toString is, which I can't remember what it is. So let's go look at the flight object over here. And toString is inherited from, see this over here. So it's basically all of that. So I'm just going to put that into a variable called toString. And that's going to be flight, whatever the flight number was, 123, departs PDX at, I can't remember, I guess it was today at a time, so I'm just going to copy stuff to make it faster here. I'm going to do all these and do a little fill in the blank. It's going to be ugly here, but it'll work eventually. Departs PDX at this time. Arrives LAV at this. Now, you've probably, I expect that you explore this first in unit tests to really understand what we should expect for toString. But, oh, someone's there waiting. But this is the whole idea, right? So that you are, this is how you test your main method. You use invoke main to, send your main method some parameters. And then you assert that the what was written to standard output or to standard error contains what you expect. Like this toString variable. Well, you might want to change it to something like expected also, because maybe toString is a little funny. Okay, so you got it figured out. Nice. So yeah, I'll commit this and you all can look at it. Example, happy path. This is going to cause everything to fail, so I will, because I haven't implemented it, of course. So this marker is disabled. Example, happy path integration test. Printing a flight provided on the command line. Cool. There was a question in chat, a couple of things in chat here. Let's see here. From Greg. Can you show us an example of a few commands for the project one? I'm still having problems with the project not loading my integration tests. So yeah, you can run project one from the command line. Now I don't have it implemented very much, so let's see here. Yeah, let's just use this screen on the left here, and we'll go back to actually it's mine. Yeah, we're in 2025. And we'll go to the airline directory. So let's see here. Let's just go over to the project one class. Yeah, this thing just prints command line arguments, then prints everything back out at you. So I can, actually I don't think I'm just going to do a quick Maven clean verify to see just like is everything working, Maven W. This will go through and rebuild everything in the project from scratch. I don't remember the last time I built this, so I'm just going to start over here. So as you may recall, we'll talk more about Maven tonight actually. The clean phase goes and deletes all of the generated artifacts that are in the target directory, and the verify phase basically does an end-to-end build of your project, starting with compiling your source code, compiling and running your tests, building the artifact like the jar file, and then running the integration tests on that. And so when I do this, I now have a jar file in the target directory called airline 1.0.0.jar. And if I run it with hello class, it always prints missing command line arguments, and then it prints hello and class. So that's how, so this is how to invoke the main method from the command line. So I will test your project ones. I will build the project. Actually, I'll build the code that you submit from a project that I create, and then I will run the main method by using this executable jar. And so similarly, I could, like from that test that we just wrote, if I took all of these strings, and actually I can just do that, so it shouldn't be too tough. So like if I wanted to execute that in the same way, I don't need these. Actually, I do need the quotes there because it's a two-word argument. But yeah, otherwise my command line would just look like this. Oops, I must have a unterminated. Oh, there it is. Yep, unterminated quotation mark. Right, and so yeah, that is the command line for running it on the command line. And then what you would do is change this code to parse the command line and create the flight based on what was passed in after validating things like the airport code and the flight number and dates and times. I'll put this back in that test in case anybody wants to look at it. I'm just going to put the $sign there. So doing that as a prompt. Yeah. Greg, did that answer your first question about some of the example commands for Project One? And actually, and maybe I misunderstood. Like, what kind of commands were you talking about exactly?
No, I think that's great. Sorry to take more time. I just
No.
wanted
We're
to
here to
kind
answer
of
your questions.
yeah, I just wanted to get some clarification on whether or not we should assume that flight already exists within the class, and it sounds like the command line commands are supposed to actually create that particular flight. Okay,
Yep.
got it.
Right. Yeah. We're really
Um,
starting from scratch. We're starting from scratch here. So yeah, you
okay.
create, the main method will always create a new airline, always create a new flight, and add the flight to the airline.
Okay, gotcha. All right. And then we'll do error handling for each command as they come in. The print and readme are optional, but they're always going to call the toString of the corresponding flight if you call print, and the readme is always just going to call the project's readme,
Yep.
regardless of what the parameters are, correct?
Yes.
Okay,
Yeah. Yes. And of course, print won't make any sense unless you have a valid flight described on the command line.
got it. Okay,
So,
that's good.
yep.
Okay.
Yeah, because you can't have a partial flight, and all data should be validated before the flight is created. Which I guess didn't explicitly call out. I hope uh, that was clear.
Also, just sorry to interrupt you, but I want to ask one more clarifying thing.
Sure.
So, you have to have all of those arguments in order to produce a valid output, correct?
Yeah. So all of it,
Okay,
great question. Yep. So all of so there are arguments and there are options. And so the arguments are, these things, and these are all required.
gotcha.
And the options are, well, they're optional. You can have one or both. Although if you have the README, it won't matter if you have print or not because the README just prints README and exits. Yeah, great questions.
Thank you so much.
Yeah. Yes, the options always precede the arguments. So print and README, and then like in Project 2, you saw you have the dash text file. All those appear before the first argument. Let's see here. Yeah, I think I answered the other two questions.
Just to follow up too, so you have the 6 command line arguments that can be supplied, but you cannot provide both print and readme at the same time, correct?
You can. It's just
Okay,
that README trumps everything else. You'll
gotcha.
see in
Okay,
Project 2 that, yeah, you can have dash print and you can have dash text file. So just because of the semantics of README, whether or not there's a print is kind of irrelevant. So, yep, you can. It's not an error if
gotcha.
you have dash print and dash README. It's just that you'll never see the output of the print.
Got it. Sorry.
Nice. Let's see here. Logan asks, I made it so you have to enter with a 2-digit date and a 2-digit month. I think that'll be problematic. I'm pretty sure. I mean, like, look, valid dates. Some of the examples I have here have a one-digit month, and a one-digit day, and a one-digit hour. It's almost like I did that on purpose over the years. So, thanks for asking, Logan. But no, you'll need to. The program will need to support a single-digit month, day, an hour. Minutes will always be 2 digits. Yeah, go ahead and resubmit, no problem. Minutes will always be 2 digits. Years will always be 4 digits. But the other components of dates and times can be 1 or 2. Oh, that's a good point. No, there's no restriction on the flight number. Yeah, I guess you could have a 1 digit or as many as you want. Nice. Okay, good. Anything else about Project One that I can tell you? Yeah.
It says we need to implement all the abstract methods.
All the abstract methods of, yep, abstract.
Abstract airline has a two-string that is
Abstract airline, you said?
yeah.
Oh, no, actually, so both the two strings are public, but they're final. So you can't override it. The flight, and actually it's the same thing with flight. Um, flight also has a, flight also has a two-string method, which is public and final. So yeah, two-string, and the intent here is that I want the format of the two-string to be the same for everybody so that the graders don't need to like guess at your two-string, or you don't lose points as like, oh, you forgot to include, the destination airport. It's not going to happen because the two-string is basically implemented for you. You just need to implement all the methods that the two-string calls, right? So like, number is abstract, source is abstract, and here the two-string invokes those methods, but you need to implement them in your subclass. Question. So dash print will call the flight's two-string only, right? Not the airlines. Correct. Dash print prints out the flight, not the airline. Yeah, good question. Yeah. Oh, the getters and setters. You know. No, I mean getters and setters don't need tests. As a matter of fact, if your getters and setters aren't exercised by like regular unit tests of more interesting scenarios, you probably don't need them. And as a matter of fact, in the case of like the flight, I think we talked about this maybe a little bit either on Slack or last time. You may want. There is no use case for setters. But once you create your, you take the flight information from the command line. Once you create the flight object, those things never change. So, a perfectly reasonable way to implement it would be to provide all of the number and the source, the parking string, all that kind of stuff in the constructor for your flight class, assign them to final fields, and only have getters. Nice. Let's see here. I wrote the constructor test to determine valid input. Is that expected test scenario correct? Oh, interesting. Oh, that's a great design question. So yeah, the question is like, where should the input be validated? I don't have a hard and fast recommendation on that. There are multiple schools of thought. There's one school of thought that says, if you are fairly certain about what the inputs to your program or your class are, do the validation there so that whenever you see a string that represents like an airport code, it's been validated already. there's another school of thought that says that you should validate as internal to the program as possible. Like, so for instance, yeah, validate in the constructor and then only assign it to that final immutable field once you know it's been validated. I don't have like a hard and fast rule for this. It's something that I want you to experiment with and see what works for you. Now, in Project 3, which we will talk about tonight, we'll see that dates and times are stored at using the local date time object, local date time class. And there might be an instance where you then refactor your flight to, instead of storing your departure and arrival times as strings, you could use those local date time objects. And in that case, because there is and local datetime objects can only be created from valid strings. So therefore, you've got like a special type that represents the date and time. And once you have that, then you know it was a valid string. There's no more data validation that you need to do on it, other than saying like making sure that the arrival time is after the departure time. But, yeah. We'll talk about that in a little bit. Oh, exception messages. Very good. Well, first of all, stack traces should never be seen by the user, so make sure to handle the exceptions that are thrown. And then, yes, if you have an error message of any type, please write it to standard error. Let's see here. Most people on Stack Overflow had a debate about it. That sounds exciting. Mentioning to throw only check errors and not runtime errors. Some people also said it was silly. Yeah, right. Oh, yeah. And there's the whole question of, should you use checked exceptions or unchecked exceptions? I think most people agree these days that unchecked exceptions are the way to go. But there's something to be said for having a specific type of exception that makes it very clear what kind of error you're getting. I think we started to explore that a little bit in the student class with saying things like, invalid GPA exception or GPA too small exception. Again, these are design choices. And the nice thing about code is that it's always considered really easy to change your design, right? You're not building a building, you're not building a highway, you're not building a rocket ship. Little design changes can happen all the time. We'll be exploring that starting next week when we learn about refactoring. Oh, good question. I'm a bit confused about what visible for testing is used for. Yeah. So visibility, right? Whenever you learned object-oriented programming, you learned about private fields and protected methods and public methods and things like that, right? So there's a whole visibility thing. And I'm trying to remember what my example was. My example was something about, probably in Project 1, is there, yeah, visible for testing, right? So sometimes you've got a method, is almost always a method, it could be a field, but you probably want to use a method, that is used by your code under test, but its functionality might be complex enough or interesting enough that you want to write tests for it. And so normally, a method like isValidDateAndTime would be private to this class, right? It does the validation for, is a date and time string, is it valid? And so normally it'd be private. But, if you want to test this method, then you make it, package visible by not putting any access modifier on it. And there is this visible for testing annotation that comes with Google Annotations that is basically a key to the reader of the code saying, hey, the reason that this method is not private is because it's used in testing. It's not required. It's just a nice little, it's something that I like to do because it just kind of reminds you, oh yeah, that's why this method is public. And I guess now that we have IDEs and stuff, it's probably not that important because you go and you make it private, then things will start, your test will not compile anymore because they're calling methods that are private. I hope that explained it nicely. Nice, great questions. Okay. Anything else on Project 1? Any questions on Project 2? That was assigned last week. Anybody had Thoughts or anything? That's all right. We can probably catch up on it on at Wednesday's class after project 1 has been submitted. Okay. Oh, another question came in. Checked. Project 2 is due next Wednesday, I believe. The projects are always due on Wednesday. There's the koans. Sorry. Oh, until I got scrolled to the wrong place here. Project 2 is due, yeah, February 5th. February already. Yeah. Yeah, right. So, but hopefully, the intent they build on each other, and so then you'll be able to reuse a lot of your code from Project 1 in Project 2, and we'll see Project 3, which again just builds on things. But yeah, there's a here in the middle half of the course, there are the projects come. You get a new one every week, and each one has 2, but they stack on top of each other. But that's what will get us to Project 4, and most importantly, Project 5. Because Project 5, the REST API, it's a whole new thing, and I want to make sure that everybody has enough time to be able to grok it. Awesome. Okay. So tonight we're going to talk about continuous integration. I've got a handout here. So, this is one of, well, I was going to say advanced concept in the course. I don't think the concept itself is that difficult, but it's something that you probably haven't really encountered before. Or if you have, you only encountered it once your projects got sufficiently complex to be, well, interesting. So, when you think about how you build your code, it's almost always these days, unless you're have one of those cloud-based IDEs, you're running on your own machine. So whether it's your laptop that you're using, or maybe you've logged into the CS department's machines, you have your own environment. You have your own checkout of the code. You're making local modifications. You're running the tests yourself. And maybe if you've got a complex test, you're off, querying a database or something like that. But it's kind of yours and your environment. Our code doesn't live in isolation, and it's very rarely just our code. We share our code with other people, like you all did with the katas, right? You were sharing code back and forth, and so we've seen how to use GitHub, for instance, to go through this whole process, this whole workflow, where you write your code yourself, you commit it, you get the test running locally, and then you push it out to other people for them to use. And as long as only developers are working with it, well, okay, that's great. Everybody can sort of work in that same way. But if you think about where your code ultimately resides, that's not a development environment, right? So either your code is, like the old days, or not the old days, or traditionally, code is assembled and then sent to people on floppy disks. Is put to is posted up on your website and they download it, for instance. So hey, you're you can get it that way. Or if you are writing a software service that is hosted, your code is then published to or the artifacts from your code are then published to some server that is serves a website or a REST API or something like that. So the reach of your code is well beyond your development environment or the development environment of your peer engineers. Lots of people consume it some other way. So it begs the question: well, what happens to the code between you writing it, pushing it to GitHub, other developers using it, and then getting to where ultimately it goes, getting to your company's website to download, getting to an Amazon Web Service that serves it up? Well, this is a problem that evolved over time, although it was kind of a rapid evolution, all things considered. So tools like Maven standardize the build process for Java applications in this case, but there are equivalent tools for essentially every language now. Because it was primarily motivated by developers to make sure that everybody had a consistent way of building the software, right? I mean, it used to be is that yeah, sure, you shared your source code with someone else in your office, but you all had different commands for building it, and like, oh, we sort of do it piecemeal, and as a result, there was all of this like, it works on my machine, I don't know what's wrong with yours. Well, because we're following different steps to build it, or oh, you didn't have the right version of a dependency or something like that. And so then tools like Maven began automating the process of building. And then they realized, and so great, everybody had the same build process, but you still had sometimes you had problems like, oh, it works on my machine, but not your machine, because the machine has a different configuration. And so they realized that what we need is to have essentially a clean room implementation of the build. And ultimately, you want a controlled environment in which your software is built, so you can produce the artifacts that have like really good pedigree, that it's not influenced on by the machine that it's built on, and then you can publish that to its eventual destination to be consumed by your users however they consume it. This process is called continuous integration because you build your source code every time it changes. So the whole idea is that you've got some machine out there that's sitting there looking at your repository, your source code repository, and when someone makes a check-in, it kicks off and says, oh great, there's no new code to build. Great, I'll go get the latest build and I'll run the entire build process. I'll start from scratch, from clean, and then which actually can even mean a clean system. So these days you have a new virtual machine that's provisioned just for your build, and then it goes and it checks out the source code. It's well, actually I probably have like a whole list of things that it does down there. So it basically builds things from scratch. And so this has been a really good thing for software development because it allows us. Well, well, first of all, it builds things. So it tests your build process. It makes sure that you can build your artifacts starting from scratch, and again, doesn't rely on any particular machine. Also provides resiliency. I remember when I started my career, sure, I built it locally, but actually there was a person at work whose job it was to create the official builds. And basically, this person, drank a lot of coffee all day, and then like at 5 p.m. when everybody else went home, okay, that person pressed the button. Well, actually didn't press the button. That person like went through all the steps to make the official build, so that when we came in, the next day, all that code, the changes from the previous day, would be available for people to consume. Now all this stuff happens automatically. And because it happens automatically, and because it happens within seconds of the code being committed, you get very rapid feedback. So, oh wow, look, your change broke a test. You find out immediately. Oh, your test, your change made it so it doesn't compile anymore, or that, oh, there was a missing dependency, right? All those things are found out very quickly, and it's found out well, if it's found early in the early enough in the build pipeline process, no one's affected by it. It's not like anybody gets a bad artifact in their environment. The build pipeline, yes, it builds the code, but there are all of these quality gates that you can put into it. So, for instance, you can have it analyze your source code to see if your source code has obvious bugs in it, or if you're using really bad patterns, or if you're using a third-party library that has known vulnerabilities in it. All this can be integrated into your build pipeline, and so that it's run with every change or periodically. But it's run. It's run often and automatically. And a person doesn't need to remember to do it. And then because we have this automation in place, we can work in smaller batches, which is so huge, right? I mean, we've all done it, right? When you, when you spend an entire day writing a bunch of code, and then you go and run it and completely falls over, and you're like, oh my gosh, of the 1,000 steps I took today, which was the one that introduced the bug? Well, if you work in smaller batches, you find the bug right away. It's like test-driven development, right? Where if you have the discipline to say, well, I want some behavior, I'm going to specify what that little piece of behavior is, and just write a little code to implement it, all of a sudden, you don't write bugs anymore because you're demonstrating all the time that your code works. And because of that, stuff gets out the door faster. And stuff gets out the door faster with demonstrable quality, which is why the build pipelines are so important. What the build pipeline gives you is demonstrable quality that your code does what you expect, and the code that comes out at the end of the build pipeline is indicative of the code that went into the pipeline. So this is kind of the way a continuous integration server works. It periodically polls source code repository for newly committed changes, or gets notified, depending on the source code management system. When a change is detected, it will build a new environment and run the build process there. And then if there's a problem, it alerts people or kicks off some other process and stuff. So you'll get an email, or a message will pop up. Back in the day, they had little bunnies that would light up and things like that if an error occurs. So again, it gets the latest source code, it builds the code, downloads all the dependent libraries it needs, any tools it needs to build the code, assemble things, run all of the automated tests, both unit tests and integration tests. It'll run an analysis on the code. And of course, if any of these steps fail, there's no reason to keep going, really. Because, I mean, hey, if your code doesn't compile, do you really need to see if it's got any, dumb bugs in it? Maybe it does, but it's like, let's get it to compile first. So yeah, it'll run analysis on the code to make sure that there is anything problematic on it, so well-known anti-patterns. It can do things like generate documentation, analysis reports for people to view. And it also packages up all the artifacts that were built, like the jar file, or we'll see their web application files. I mean, all the things that are needed then to really make your program, your service, whatever it is that you're building. And then once it does all that, and here again, guarantees quality along the way, or rather, assess and validates quality along the way, it'll take those artifacts and deploy them to wherever they go. So maybe there's a repository that your artifact goes in so that other people can consume it, or it publishes something up to a web service or to the cloud, so that other people can use them. So that's what continuous integration is all about. It's basically these, this process, automated process in the background that builds your code and gives you continuous feedback on the impacts of the changes that you've made in your code. Now, there's a lot of continuous integration systems out there. GitHub, a couple years ago, introduced something called GitHub Actions that make it super easy to put together one of these build pipelines for your GitHub repository. And so if we look in, here's the, any repository created from the Getting Started repository. There is a there's a .github directory that has this workflows directory in maven.yml. And what this does is it describes a build process for this code base. So it gives it a name. I just use the out of the box one, Java CI with Maven, which actually is exactly what it does. So it's probably a reasonable name for it. GitHub supports, a whole slew of languages and build tools and stuff. It's it's in their own best interest to make this kind of stuff easy, and it's a great service they provide. So this says things like the following: hey, listen, build, trigger a build whenever there is a push to a branch that is called main or ends in -snapshot. Same thing with if there's a pull request created for main or for one of the snapshot branches, that's when you trigger a build on change. This way you can do things like, commit into other branches and won't try to build it right away. It's only like when you want to merge into, either want to merge via pull request or do merge by pushing that you want to trigger the builds. And so then what does the build actually do? The configuration is actually pretty small. It's nice. So you say, hey, here are the jobs we want. Here's the build. We want to say, hey, provision me an Ubuntu machine that runs the latest version that GitHub supports. I want to build my source code with 2 versions of Java, Java 17 and Java 22. This is a kind of common thing. You want to make sure that your code works with multiple versions of the platform that it runs on, especially if it's something you're going to be distributing to a lot of people. And then for each one of those build configurations, here are the steps I want to follow. This means check out the code from GitHub, and of course it's GitHub running this itself, and so it'll check it out. And then it, well, I give it a nice display name here, and it basically sets up Java, a Java development environment. So it'll go and download the particular JDK version, either 17 or 22, that's running. It'll install it. It'll set up the environment to use it, to build it. And you can tell it what distribution. It's the Tamarin distribution. But if you want to build it with a particular, you want Oracle's Java. Oh, you want Amazon's Java. Great. You can do all that. And then after it has checked out the source code, after it has set up the Java environment, then it's going to build the source code that was checked out using this command line. And it looks pretty familiar, right? You use Maven W. I'm going to use this batch mode so that we don't have to deal with all of like the escape characters for the colors on the screen. And then we'll run the verify phase. Now it starts from a fresh checkout, so you don't need to clean anything. That basically runs your entire build pipeline. It'll go through and do it. And then I specify the pom.xml file, I guess, just to be overly explicit. And so if you've got one of these things, if you go over in GitHub, I guess I'll just look for it here, GitHub, and then I want to take a look at Code 2025. Right, we have our pom.xml file here. When you have pom.xml, the maven.yaml, when you have one of those, then you get this actions tab here. And these actions are the builds that occur. And if you notice, every time I make a commit, another build is run. And so like right here, whatever it is, 29 minutes ago when we were messing around with the Project 1 IT and I made commits, right, when I changed the code to add like, this line right here, when I push that up to GitHub, because I had it configured to, actually I guess it'd be on this one, because I had it configured to, I pushed to my main branch, I said, oh, when there's a push to main, rebuild that. It triggered this action with the, this is the message, the commit message right here. And then it said, great, it went in and did its thing. It gets 2 jobs, one for each JDK. Oh, that's good to know. Oops, I didn't want that. I guess it's warning me about a couple of things that are happening with GitHub. Well, that's nice. But now I can get details about the 2 jobs. I can see, oh yeah, what happened on Java 17. And there's a big old piece of output that tells you all of the phase. Where you set up, and here's like running the checkout action. Here's setting up JDK 17. Build Maven project is probably the most interesting one. And here it's running my command, my Maven W batch mode verify-file pom.xml. And here is the output. So it goes through and it downloads all the artifacts for you, because it's running this on a newly provisioned VM. And of course, this is huge, so it's not very interesting. We're going to scroll down to the end. And it goes through, and ultimately it was successful with all of the projects that are in my repository. And it does this automatically whenever I push a change to GitHub. And so it gives me great feedback. Because if it fails, I'm going to go back to the code. If it fails, a couple of things happen. First of all, instead of a green check mark here, you get a red check mark. And actually, I think if I look at my commit history, yeah, it tells me, like, here are, so at some point, I think I must have written a failing unit test. Actually, we can even go look. We got a red X here for the continuous integration because things started failing. As you can see, okay, great, the checks have failed. And why did it fail? Well, I think it'll open it up here to the end. I'll scroll down to the bottom here. Oh yeah, we'll find there were some errors, and it looked like the student project failed. And then, yeah, great. Here's where I wrote a test that it failed, and I can see why. So here again, what you get is this information. You get this feedback. And oh yeah, by the way, when I did this, I got an email telling me, it's like, hey, your build failed. Which as a developer is exactly what you want, right? You want to know as soon as possible when you've inadvertently committed something that that doesn't work. And that's what continuous integration is all about, is providing that feedback in a way that is automatic, that doesn't involve another person, so that the people can be, the humans can be focused on adding the new stuff, doing the cool things, making the big impact, and then we have automated process. We have the machines that are good at what they're doing, right? Following some steps, doing things increasingly faster and faster because machines are always getting faster and better. Yeah. So anyway, this is all the stuff that happens in that Maven.yaml file. So bottom line here is that continuous integration was really a very, even though I think it seems like totally straightforward now, it's like, well, of course you did that. At the time, it was very innovative. And at the time, it was one of these things where it was a light bulb moment for so many people. Because it's like, oh, wow, we've been doing this wrong for years. But, once you had the confluence of source code control, of automated builds, of the ability to create VMs, the ability to, stand up these machines, and have all this stuff be automated, it really, made it so that software could be developed much faster. So if you'd like to learn more about continuous integration, I got a couple links here in the handout. I do encourage you to learn about it. It's a very common practice in contemporary software development. Oh, do I enjoy working with Docker? Oh, wow, that's a loaded question. I like what Docker can do for me. I've also seen Docker be used for things that haven't been effective. Okay, so I'll just take a quick detour for Docker here. So Docker is this really cool system that leverages the fact that modern operating systems can have sort of some kernels in them and things like that. That basically give you like a little virtual machine environment inside a Windows operating system or standard Linux or anything like that. And Docker has what Docker provides is the ability to sort of very easily through configuration create this little like mini OS image that contains your application, contains your service, what you want to do. And there's some really great use cases for it. So we use it at work for standing up databases, right? I mean, have you ever tried to install and configure an Oracle server? Oh my God, it's like even when you know what you're doing, it's still like a day-long process. And so like something like that, if it can be automated into a 10-minute process, that's a huge savings, and Docker can do that, and that's awesome. Same thing for you can have these pipelines where if like you are familiar with running Docker, it can work really well for you. And you can orchestrate all the containers, and so you can have these the systems like Kubernetes that will go and again get all your containers running and configure them so they can talk to each other and everything like that. Really cool stuff. Can get really complex though, and so then. And actually, it's kind of neat because if one of the containers falls over, great, Zookeeper or whatever, we'll just like stand in there, run back up again, and that can work really well. However, I've also seen containers being abused in that your microservices are too small, or that you have, you have a hammer and everything looks like a nail, and so I've seen applications that have been architected in a way that was really counter to what was needed. So just because you can, decompose your application into, 100 different microservices that all talk to each other over REST APIs doesn't mean that you should, because you can be very inefficient. And by doing that, you introduce a tremendous amount of asynchrony into your system, a tremendous amount of parallelism into your system, which is overkill for many problems. So I think there are things I enjoy working with Docker, and there are times where I wish we had never done Docker. It's like, just put it all together. It's not going to be that big of a monolith. It's okay, because it's actually way easier to reason about something. There's less chance of race conditions. Of course, you can always have race conditions, but they're so much easier to diagnose when everything's all one process, and you're not like trying to aggregate log files from all over the place. So yeah, so that was a little rant about Docker. Okay. Yeah, thanks, man. Okay, continuous integration. So actually, have you encountered stuff like this before? Have you used this in class or heard about it or used it at work or something? Yeah, some people are kind of maybe. Okay, cool. Again, this is something that that you get for free in this course, and actually, I mean, this is a question I should have asked. I mean, have some of you noticed that when you check in code that breaks your build, you get an email about it? Well, this is why, right? And this is just one of those software professionalism things where it's like, yeah, you want to know, don't you? So I hope you do, right? And sometimes, I mean, it's annoying. I know I do that too, where it's like, yeah, I know, I just I checked my code and I know the test didn't pass, and that's all right. But other times, it's like that other time where I wrote the test and I thought it passed. Actually, that passed on my machine. Um, and I was just so glad to know. It's like, oh wait, it didn't pass on GitHub. I'm like, oh yeah, right, because like GitHub's running it in a different time zone. Oops, and like my code was not resilient to different time zones because it assumed that it was always running on Pacific time instead of GMT. It's like, wow, great learning. So thank you for the feedback. Okay. Now I want to talk a little bit about Maven and our Maven projects. So, oh, what do I want to do? I know what I want to do. I want to go down to. There's some things in here, which which we really haven't talked about yet. So the parent POM. So we've seen POM.xml files before. You've done things like put your name in them for the katas. You've maybe you've noticed that the name of the main class is there in the pom.xml. Oh yes, right here, like for student. It's there. I do encourage you to watch the Maven lecture. It's there's a lot of stuff there, and I'll be completely open. It's not like you'll need to, you won't be writing your own POM files. You won't be writing your own Maven projects. But I do encourage you to understand enough about Maven so that you know about a build tool. It's important to know how your software is built because otherwise it can be a lot of magic, and magic can get you into trouble when something goes wrong and you don't really understand how all the pieces and parts fit together. I think the first thing I want to talk about, why is there this underlined in red? Yes. So, yep, that would do it. So I think as some of you have noticed, like when you rebuild, I'm going to rebuild my Maven project here. I'm going to reload everything here from my Joy of Coding repository. There are a couple of Maven errors that Maven warnings. Actually, there are Maven warnings and Maven errors that kind of pop out at people, they say, "Hey, what's going on here? How come things aren't nice and clean?" So, for instance, I think we see it if we try to run the top level here. There might be some warnings about the POMs and how they relate to each other. Let's see here. Wait a second. Have I got you yet? Let's see here. No, it's complaining about the Enforcer plugin. There's all sorts of stuff here. Okay, so maybe it doesn't show up in that output. But as I note here, you might see some warnings. Oh yeah, right. Like these, some of the problems were kind of with the building the effective model. We get things that mention things like parent.relative path. So in our repositories, there is there are nested projects, right? So you have a top level project. You have a top level pom.xml, and in it. Oops, oh wait, sorry, that's not the top level. This is the top level pom.xml. You have these submodules for projects like the koans and the student and the airline. And these are POM files also. Actually, you can navigate to them by doing Control-click or Command-click. And now you get to the POM file for the koans. Now, when we create them, the archetype that creates them specifies their parent to be like my top level joy artifact. And this isn't the parent. This isn't actually the proper parent. The proper parent would be the one for this repository, not the one that comes that's out there on Maven Central for download. So one of the things that you can do to get rid of those warnings is patch this stuff up. by having it refer to yeah, your group ID and your top level artifact, we call the joy of coding. So I'm going to make some changes to the pom.xml files, sort of talk about how Maven is all, how to properly weave together Maven projects. So we want to change your user ID in this file to my user ID. So I'm just going to do a search and replace by saying edit, replace, find, and replace. So your user ID with just Whitlock. So like 2 of them, I'm going to replace them all. And then replace my GitHub user ID with my GitHub user ID, which is David Whitlock. Oh, and it looks like you can replace all of those. Replace all of those. This one needs to be in lowercase, so I'm going to actually replace this. I don't know how many times it exists with lowercase. Just one. Nice. And we'll see what all of this stuff and why this stuff matters here in a little bit. Okay, so now I've made a change to my pom.xml, and IntelliJ is telling me that I need to reload, basically IntelliJ needs to rescan the pom.xml to make sure that it understands how your project is still structured. And so you see this little icon, which is the M for Maven with a little refresh symbol in it. And so you can click there, and then it goes and loads things again. And the next thing I want to do is I want to go back. Actually, I'm going to commit this change. I'm going to say, rename, well, let's see here. Fill in, specify my username and GitHub ID. Two things, one word, in the top level pom. I'm going to commit and push that up there. And by the way, that'll kick off a, you can see it running. That will kick off a continuous integration build. Come on. Up to the top. Yep, now it's got a little yellow or amber dot, which says that, yep, a build is pending. That's kind of cool. Okay, so you can, again, sort of like, okay, in order to get rid of these warnings, you need to adjust the parents for those child projects. Instead of it being like my highest level highest level parent pom, we're going to use the joy of coding one for this term. So we're just going to take these folks right here and then apply them to each of the children. So let's see here. Yeah, so for koans, its parent won't be just the top level joy. It'll be this joy of coding. And for, let's see, back. And for student, we're going to do the same. And this gets rid of some warnings and also just makes your projects better formed. And then airline, oops, airline poms over here. I'm just going to move it. I can't move it. Move that to group. This hooks everything up nicely. It has the proper parent-child relationships between these modules. Okay, and now actually I'm going to see just to make sure did my code pass. I'm going to look at actually my actions. I wonder if it's still running. Nope, it ran. Great. See, it only takes 44 seconds. That's really nice. It's super fast. And yep, it said that was okay. So I'm going to do the same thing here. I'm going to correct the parent pom reference in submodule projects. I'll commit and push that. See here now if I reload it again. Yep, there's a got a new one. Sweet. Okay. Now let's take a tour through these pom.xmls. I'm going to start with the top level one. Now, it's not the best XML in the world. Just make that there so it's a little easier to read. So, this is XML, which I presume everybody's sort of seen, or at least sort of figure out what we're doing here, right? The whole idea is that we've got structured data, and we have nested data. And so you have things like, a tag that says, oh yeah, this is what this thing is. Then it has child tags and then data inside them. It's all text, but it's got this structure so that tools can read it, and so can humans, for the most part. It's all, things are pretty well structured. As a matter of fact, in project 4, you're going to be working with XML yourself, so this is a good way to get introduced to it. And so you're saying all sorts of things about this Maven project that's here. You're saying, the POM file itself describes the project, what to do with it, how it does its thing. Projects can have parent projects. So in this case, it's what we just, it's what we just cleaned up here. And notice that notice that if we go and look at the version here, it actually I don't like that. I'm going to hover over it again. Because when it shows you, I hope you can see that, it shows you where the POM file lives. That's downloaded to my Maven repository. So it got this POM file from Maven Central. So the artifacts that I create, the code that I create, I publish that to Maven Central. I have the ability to do that. And then when you use it, it downloads it from that central repository. Excuse me. And so then you also specify things like each artifact has a group associated with it. It's just a identifier for your organization. And then it has the name, so of Joy of Coding. That's sort of the top level one. And it's got artifacts have a version. And as you'll recall from the Git lecture, we use semantic versioning to version artifacts. And you can say what kind of project it creates. This project just creates a POM, but if you go and look at like the airline project, its packaging is a jar file, right? So this the project configuration basically tells Maven, hey, what we're building here is a jar file, and then Maven knows what to do with that. And you've got all this other information. So like, hey, here's a URL for the project. Here's a description of the project. Here's what child modules it has, and then you got all sorts of information about itself. Again, its year, who made it. Here's where to find issues about it. Here's what license it uses. The developer is using it for, et cetera, et cetera, et cetera. And then it has all the information that configures the build itself. That's all in the lecture. I'm not so interested in that tonight. What I do want to talk about, though, is all this other metadata, like information about, oh yeah, who built it, and when was it, when did it start, et cetera. So all this is in the pom.xml, and all of this can be used by Maven and Maven's plugins to do things that are interesting. So the thing that I think is most interesting is creating a site for a website, basically, for your project. And Maven has a phase called Site, which is meant for building a website for your project, which is standard looking. So Maven sites look pretty much the same or structured the same, and this is great for the open source community. If you end up doing a lot of work in Java, you'll get familiar with open source projects that use Maven to generate a kind of standard looking, especially Apache projects. Look what else is this downloading? Downloading the standard looking website for open source projects that are built with Maven. And so then this is nice because there's a standard tool set that you can leverage, and you get something that'll be familiar to people. So if you use any of the Apache libraries, yeah, you know where to find information on their website, like where their API documentation is, where to contact the developers, what version of the software is available, things like that. Actually, I have some instructions on how to work with this. I'm pretty sure. Yeah. All right, we'll save the debugger for another time. Here we go. How to create a website for a project. Okay, we need to do all that stuff. Oh yeah, I'll talk about this in a little bit. But first, I wanted to show this. So, when I create my my site, I have the project, the Maven project, configured to build all sorts of reports about the project. So things like building the Java doc, building reports about which tests ran, doing code coverage analysis. I'll show them all here to you in a minute when it all finishes building. But as you can see, it's doing a lot of stuff, and it's generating a bunch of different reports for the project. How much more does that go? Let's see here. What is this? Oh, this is airlines. Okay, it's finishing. Great, it's done. So what that did is here in the target directory, in the site directory, it now has all these reports, all of this HTML, which we can open up individually, but it looks a lot better when you do Maven W site.stage. And what this does is it moves some things around so that, that you can open up like a single index.html and see like the entire site right there. Nice. So now we can open up target staging index.html. And here is the website that's generated from the Maven project. So it has information like either version of the artifacts that you created, and then this is like the name of it. And oh, you can look up to the parent project and stuff, but you can also get oh, that looks like that's not working. Well, koans is very interesting. What does it get for students? Okay, so you can get information about each subproject too, like the reports. So here you have information, all sorts of information about reports. And you know what? I think it's time for a break. We've got a lot more to dive into, but I want to take a break here. I'm a little parched. I need something to drink. I bet everybody could use a little break. So let's take let's take 15. We'll be back a little before 7:30, and then we'll dive some more into this stuff because I want to make sure that everybody is paying attention to all the cool stuff that goes by. Thanks. Okay, yeah.
You showed the Maven site.
Oh yeah, Maven site, Maven stage. I'll get back to that in just a moment. A couple questions came in during break though. They wanted to talk about. The first one is basically, hey, I'm making changes to my Joy of Coding Winter 2025 repository. Do you need to keep up? No, there's there for your example, but if you want to play along at home, you can. There's not an easy way to merge my repository into yours because they were both created separately. There's not really a common origin point. When you create a new GitHub repository from a template, it basically starts history all over again. So there's not really common merge history. I suppose if you want to, you could like get a diff from two versions in mine and try to apply into yours. It probably wouldn't work very well because my code's my directory. You don't have my code necessarily. So I don't know. Probably the easiest thing to do is to get your own copy, your own checkout of your own clone of my repository, and work with it that way. If you want to copy stuff in, just have them side by side and move them that way. So yeah, there's really no way to merge. And then another question came in about the options. They can appear in any order, but yeah, just again to emphasize, I guess I don't have the handout up anymore, but I don't. But I'll just get it up here. So like for project 1, all of the options appear before the first argument. So yes, options may appear in any order, but they must appear before the first argument. So if you see like something that isn't an option, you can assume that's the first argument. Yeah, although if you see like, sorry, anything that doesn't begin with dash, if it begins with dash, we assume it's an option, but otherwise it would be the first argument should be airline. Great questions. Okay, so back to what we were talking about before, which was continuous integration and building the website for the project. So we went through a couple of steps. We built the Maven site. We ran the site. It took a minute or two. to build because there's lots of analyses that need to be done. And then we ran this Maven site stage, which is what gives us the nice index.html file in the staging directory here that sort of weaves all the reports together, all that kind of stuff. Let's take a look at the reports that are generated in that, in that whole process. So I'm looking here at the generated reports for, oh, it doesn't say, this is airline. So that's, oh, sorry, this is student. I guess it doesn't really say student on this page, which is interesting. I thought I did. I guess if you went to project information, it would. And actually, before I go into this, I guess, I'll go back here to the parent project and look at some of the information. So by default, it generates this report that talks all about the project. It has things, it has like this text right here, source code written in the summer of, summer 2025. That's not right. That should be winter. Right, actually it came from here, right? It came from the description. So the description element is used in this report, for instance. And you can get information about the licenses, and so it knows about the Apache license. You can get information about the dependencies that it uses, and that way you can see like, oh, it uses version 3.0 of Hamcrest, and it uses this version of Mojito. Good stuff like this. And they can tell you all about these other dependencies that it uses. And this is very important information to be able to understand the dependencies, because then you can have other analyses, which I don't have here. Maybe you should go look for, is an analysis of are there any known vulnerabilities in these libraries? Beyond the scope of what we're talking about tonight, but I hope you're all aware that you got to be careful when using third-party libraries, because they're, they might be old, they might have problems with it, or they may be new and have problems with it. You need to know what kind of code you're embedding in your project, you're including in your project. You can also get information about source code management, and all of this comes from the issue management organization. Where is it? Somewhere here it has the Git. It has Git. There's issue management. Oh, here it is. The SCM connection section lists the like the Git URL from there, and I think it's smart enough to know that that's GitHub, and so you can access it in other ways. But the whole idea is that hey, you can put this up on your website, and then any developer can go and see it, and we generate it in 3 minutes because Maven has all of this stuff that comes out of the box. What's really cool though is the project reports. So here's all the reports that I have configured. You can add a whole bunch more. Maven has a plugin architecture that a report vendor, if you will, someone who creates these reports can then add a Maven plugin so that it can so their reporting tool can be integrated into your Maven project really easily. I'm just going to walk through some of these. Spot bugs is a super cool one. Actually, they might not be detecting very much, as it's only got one bug. But the whole idea here is that there's this huge database of common mistakes and bugs in Java programs. This is, where is this? The University of Maryland College Park, I'm pretty sure is who put this stuff together. And so what it does is it looks at your code, and then it will use the spot bugs tool to then tell you if there are any known problems. So actually here's a good one. So it's saying here in my student class, it says exception thrown in class student at new oh, okay, right, there is, here on line 27, there is a constructor would throw, okay, a constructor might throw an exception and says the object under construction remains partially initialized and may be vulnerable to finalizer attacks. Well, that's kind of neat. So you can go and look at that line. It's line 27, and sure enough, yeah, it throws. Oh, interesting. It says it's partially initialized. Okay. Oh, right. Okay. Well, anyway, it can find stuff like this. Now, is this really such a big deal? I don't know. Maybe I should learn more about it. And so you can click here to get more details about this particular. About this particular exception CT constructor throw. No, I would hopefully it would it would give me, oh, it looks like it doesn't actually give a, there we go. It doesn't link to it the way I expected. Right, so here's just like, a little recommendation. Now, I think this stuff is interesting. I have to admit, like what, maybe like if I was starting over from scratch, I would run all these things. And in reality, when you have like a big old code base like the one that I work on, you run these tools on it and then just find so much stuff that's kind of overwhelming. But I think what's probably most important is to spend some time studying this to understand the kinds of errors that it might find. And so then when it does find those in your code, you can triage them appropriately. Spot bugs is super cool. I'm kind of curious to see what it would find on yours. I don't run that analysis, but you can by generating a Maven site. Things like this will look for code duplication. Not surprisingly, didn't find anything because the code is really small. But you can also get just like if you want to look at the source code, you have these reports here, and actually this is what the other reports will reference this xref to be able to have a nicely formatted view of the source code, right? It's got syntax highlighting and stuff like that. This is all an HTML report. You can navigate to things. Let's see here. What can we, does it have calls? No, I guess it doesn't link to calls, but you can link to certain lines and stuff like that. This is a nice dependency updates report. This tells you if there are any new versions of libraries available. So for instance, right now we're using version 33.3.1-JRE of the Guava library. Well, it says there's a newer one available. Okay, that's nice. It's good to keep your code up to date. Again, you get bug fixes, performance optimizations, vulnerabilities removed, things like that. There's also a new version of JUnit out, right? Everything moves so fast. Like I just updated these a couple months ago. Okay, good to know. And of course, you can get Java docs too. So here's API documentation that's generated from the source code. I think we saw this last week or the week before. And and you can actually you can drill into the source code here also. It's not as nicely syntax highlighted as it was before, but this is good stuff here. And also you can see your code coverage projects. I think some of you, or code coverage reports. I think some of you have seen this already. You can drill down into the various classes here, and you can see that there is. Interestingly enough, it looks like I don't have any code that actually creates a new student. Kind of surprised by that. So this helps inform where I ought to be writing some unit tests, especially if I haven't hit that 75% threshold, which is required for the projects. And then things like summaries of your unit tests. How many passed? Everything was passed. Everything this was skipped. But if something fails, then you'll be able to drill into things. Like what is this Dave student plus detail? I wonder what that's all about. That question came in. You say spot bugs will point out deprecated dependencies or out-of-data dependencies, or will that just be in the dependency reports too? I think spot bugs only deals with bugs. The dependencies will be in the dependency report. Now, what spot bugs will do is it's really about your code. Like, are you using known iffy or known bad coding patterns? Anyway, super great stuff here. All those reports. And hey, if you go and find a tool that you like for instance, I should add a report that goes and looks for vulnerable libraries. I'm sure there's one out there for Maven that integrates super easily. All you need to do to add the tests is to actually everything is hidden up in the parent POM. So if we go to the parent POM, you'll see that there's reporting section. Yeah, there's this reporting section here in the parent POM where you can, this is where I configure all of the Maven plugins for various things, like there's spot bugs and there's the Java doc plugin and all this kind of stuff. It's really powerful, and because everything is standard, because everything's built on Maven, what you end up with is not only an easy-to-use environment, one that ends up being familiar to the community of Java developers, that leverage these tools. And just like any good tool, they try to make it easier to use the tool than to not use the tool. So it's like, yeah, might as well. And you get all this stuff for free if you're using Maven. Essentially for free. It's all included for use. There's one other thing I wanted to highlight, and I do realize that we're running low on time, so I'm not going to show it, but I'm going to tell you about it. I use Maven site and Maven site stage to create this website here on my my local machine. But what you can do is you can host the API documentation on the interesting. You can host it on the web on GitHub, the public site, pretty easily. You know what? I think I do want to go through this because it's pretty straightforward, and I'm always happy with the results. So if you in your GitHub repository, if you create a branch called GH Pages for GitHub Pages, GitHub, the website, knows to basically serve up the content that's on that branch. So I'm just going to go through the steps right here. So I'm going to create and check out this GitHub Pages branch. And I need to modify my pom.xml? No, I don't. On the branch, I need to delete the readme.md because that's going to mess things up if I don't. And then go through this. By the way, just to be clear, this isn't required that you do this, but I think it's a neat example of what you can do with GitHub and Maven. So I'm going to push that up to GitHub. And now, actually, I'll just go up to GitHub here. Actually, I'm on GitHub. I need to reload, but I should have a GH Pages branch. And it does not have a README. That's cool. And now what I'm going to do is the following. I'm going to run, oopsie. I'm going to run, I need to go with the command, which is back on the other page. Oops. There's the website. I'm going to run this site publish command, which will take the oh wait, did I need to do that? Yeah, I think it'll be okay. What this will do is it will take the Maven site that was generated and publish and basically check the site, check the HTML and all the associated CSS files and things like that into that GH_pages branch in GitHub, and so then GitHub will be able to serve it up here. That's very flashy the way it's looking. So take it a little bit. Yay, that seemed to be successful. Now, actually, let me go back to the GH Pages branch again. And it said site check-in for project Joy of Coding. That's super cool. And now, let's see here, it doesn't have a README. But now if in a new tab, I open up, let's see here, HTTPS, and I say, David, no, what do I say? Sorry, wait a second. Don't have my notes in front of me. Sites. Now, if I open up, right. So it is, this is on my website. So it is HTTPS davidwhitlock.github.com/joyofcoding winter 2025, the name of the repository. What did I get wrong there? Oh, thank you, github.io. Nice. I wonder if somebody, yeah. Oops. Okay, go away. Hide for the music girls. Nice, there it is. And now my site is up here on GitHub. And so hopefully all of this works. Well, that doesn't work very well in the first place. Yeah, now you've got all of this stuff. And so you can use it with any content, right? Anything that you want to put up on GitHub pages, it is automatically served up for you. And so I don't know, this is like a neat way of doing this. Again, it's all pretty straightforward. I went through pretty quickly. If it's something you want to do, please feel free to check out this portion of the README. But really what I wanted to do tonight is just demonstrate what was possible. Let's see here. Yep. So yeah, all this stuff is possible. And let's see here. Can you go to your deployments and click it? Greg, what did you mean by that exactly?
On like the main repo, you can like click view deployment sometimes and it'll take you to it. I didn't know. You look like you were trying to put the URL in quickly, so I was just trying
Thank
to
you.
help.
Yes, do I have, let's see here. Yeah, do I have it?
I think it's
Oh,
on
it
the
does. Oh,
bottom.
yeah,
Yeah,
cool.
there you go.
Thank you. I didn't realize it did that now. Okay, and so then, yeah, I can just go here. Oh, that's so much easier. Thank you. Sweet. So I still want to talk about Project 3, but any comments, questions about the, about what we saw tonight about continuous integration, building websites from Maven, all the reports, anything like that? Yeah, something unusual. I wanted to share it with everybody because I wanted to show you the power of a tool like Maven and the benefit of having this huge community of people that contribute to it, and makes it really easy to do some kind of cool stuff. Okay. Project 3. Okay. So then, you're in the Project 1, you are building the fundamental airline classes. In Project 2, you'll persist those the airline, the flight objects to a text file of a format of your own choosing. Project 3 builds on Project 2 by adding the ability to format the contents of an airline in a way a human can read. Project 2 is all about writing out a text file that a computer can read, and the grader has to read it too. But but mainly it's it's the program that reads it back. Well, now we're going to learn about Java's facilities for formatting dates, for formatting text, and get experience with it by adding the ability to pretty print the flights in an airline. So there are a couple of changes that you'll need to make. The first one is to the flight class. So you probably didn't need to change the flight class in Project 2, but in Project 3 you'll have to. This is when you get to work with the get arrival and get departure methods. If you go and look at those methods, they return an instance of Java time local date time. So this is a class that you'll learn about in the working with dates and times lecture, and it's basically an object that represents, well, a date and a time. And it's local in that there isn't a time zone associated with it. We're going to try to keep it simple for this. So no time zones in this project. So I want you to start leveraging this class by overriding the get arrival, get departure methods of the flight. I also want you to change the implementation of the get arrival string method and get departure string method to format the corresponding local date time using format style.short. And again, you can watch the lecture to see how to do that. So that is some changes those are some changes that you'll make to the data that backs a flight. Also, the flights in an airline should now be sorted alphabetically. Well, they should be sorted. And here's the sorting algorithm. They're sorted alphabetically by, first, they're sorted alphabetically by the code of their source. So this is the source airport, and then sort them alphabetically by their by the code. If you have two flights, or if you have multiple flights that depart from the same airport, they should be sorted chronologically based on their departure time. And if you've got two flights that depart from the same airport at the same time, we'll consider those equal. Now, if you watch the collections lecture, you'll understand about the semantics of equal objects and before and first and last and things like that. I encourage you to use the comparable interface on the flight class, have flight implement comparable, and then capture all the logic for sorting inside the compare to method. So flights store their dates and times using local date time. Flights are comparable, and so they can be sorted when they are in a collection. And now, like the new piece of functionality, or at least user-facing functionality, is something called a pretty printer. So a pretty printer is another type of airline dumper. Airline dumper is the interface that you use for your text dumper, and it's also going to be used to implement a pretty printer. And the whole idea is that a pretty printer creates a nicely formatted representation of an airline's flights. And this gives you an opportunity to use Java's facilities for formatting dates and times, formatting text, things like that. Also, there is a class called airport names, which gives you the name of an airport. It's got a whole bunch of airports in there, and you can go and look it up. In addition to all that information that should be in the pretty printer should also include the duration of each flight in number of minutes. So you need to compute the duration in minutes and include that in the pretty output. So all of those changes are used in your Project 3 class. So Project 3 is your main. Has the same arguments as we've always had. Plus, there is a new argument called -pretty. So it's got README, it's got print, it's got -text file that we saw in Project 2, and now in Project 3 it has -pretty. So -pretty is basically has the following semantics. When that appears in the command line, the pretty representation of the airline should be printed to a text file specified by the file by this next argument here, file, or if the name of the file is dash, so -pretty space dash, then it should be written to standard output. Some additional information about the main class. Note that the 3-letter airport codes given on the command line should be case insensitive starting in Project 3. Note that if we pretty print the airline, it should be printed after the new flight has been added. So please add the new flight and then pretty print it. And there's a change to the date and time format. So we're not using 24-hour time anymore. Now we're using 12-hour time. So now the date and time consists of 3 command line arguments instead of 2. The first one is the date. The second one is the 12-hour time, and then an AM/PM marker. And I think PM is always uppercase. Yeah, I'm not going to support lowercase AMs, PMs. I think it says here someplace. So a bunch of footnotes there with giving you a pointer on where to start for date parsing and date formatting. Some additional error handling that you should consider for this project. Obviously, the command line's wrong. Or if the format of the date and time is incorrect, you'll be validating that differently now, or you could validate it differently. This is the project that will check to see whether or not it is an error if the flight's arrival time is before its departure time. So again, no time zones, but now I want you to learn to use these Java APIs to make checks like this. And it's pretty easy once you understand the APIs. And it's also an error to have a three-letter airport code that doesn't correspond to a known airport, and all the known airports are in that airport names class. So again, this is an extension of Project 2, just adding some more additional code, which gives you an opportunity to explore dates and times as first-class objects, gets you to explore the collections API, understanding how to sort objects that are comparable, and then formatting a text using the pretty printer. That's due on February 12th, which is 2 weeks from Wednesday. Any immediate questions on that? No? Okay then. Well, that's everything for tonight. Thank you very much. On Wednesday, we'll be back with our second pair programming activity. Please attend in person. Bring your HDMI cable if you have one and you want to use it in the room. And I will see you all then. Thank you. Oh, there might be questions. No, just thank you. It's good.